Okay, so this session will be a lot of theory and some history, because I like to dive into things like that. And then we'll do a bit of assisted coding, not with AI, but you shout things at me and we do them. That's the way I think about this assistance. How does that sound? Good? Okay. Also, you don't feel pressured to verbally give me signs. You could just be like, thumbs up, that's fine also. I can see that. Okay, I think we can get going. Right. So, building agents in JavaScript. I'm Daniel Phiri. You can find me most places online as Malgambias. I do development experience at education at Weaving, an open source vector database. I'm a writer, developer, and an artist. I moonlight as a techno DJ tonight. So I wrote this talk because at some point, this was me. It's not very clear, but this is someone who is staring into the void. And in this void, they see a reality of the future of application development being Python-based. You know, with AI being what it is today and how much space it takes out. I've written Python before. I know maybe a couple people have written Python here also. It's a bit of a pain for like large-scale production applications, or sort of just like, you know, building anything fun. So this was me, and that's why I sort of wrote this talk, because I had this worry. Where is like my place as a JavaScript developer in this like ever-changing world of AI? How do I take advantage of this? And the current hot thing in AI, I guess, is agents, right? Everyone's building some sort of agent. And so do not dismay. Like, you don't have to worry. There's a lot to do in the JavaScript world. So let's get into some definitions. So the idea of agents, to be honest, isn't very new to us, or isn't a new term, right? They've existed for a long time. The only thing that's changed recently is because of how performant today's large language models have got, and all the advancements that these have made, agents have sort of taken that step back into the limelight, right? We had a lot of chatbots previously, a lot of really different things in like the GPT 1.0s and GPT 2.0 eras. And so that's just to say that agents have existed. You probably used them in some way, but you haven't known. Now you're probably forced to know what they are, and so we'll get into that, right? So to define an agent, I like to think of them as executors of our will, if I can use that word. So these are sort of autonomous, and then it's a very wide-ranging definition, either semi or fully autonomous systems that use a large language model. And by large language model, I mean these generative models that can sort of create these large amounts of text. And we use this ability of these agents to use large language models to either create new information, solve extremely complex or simple tasks that we might not want to do. And so that's my definition of agent. Fully autonomous to semi-autonomous. Uses an LLM as its brain and can solve some sort of task, right? I made this really nice shirt with AI, of course, which is executor of our will, because we're joking about how lovely that would be for a band name. So if anyone wants one, let me know. They will never come to production. So a bit of history on how we got here. So this is like a very brief history of large language models, where we've come from, and how they sort of came to importance, and how agents are sort of where they are today, right? Like I said, they didn't pop up from nowhere, right? Like they've been around quite a long time. But let's go to like the genesis of this new spread of AI excitement, which I think was around GPT 3.0, right? I think that's where everyone was like, wow, what is this thing, right? So a company called OpenAI launched this service where you could interact with a large language model through a web interface, and that was revolutionary. Everyone started doing something really similar, right? And then another company called at some point released this tool that they dubbed computer use. So essentially, you had a large language model which you could prompt these models in, essentially predict, are trained off a large data set and predict what the next possible token could be based off whatever input you put into it. Now, computer use was a big change because it took this interaction that we had with these large language models outside of our browser and onto our devices. And so essentially I could type something and say, hey, build me a web server, or rename a bunch of files for me, right? This was possible in Python, but the ability of a model to think and reason through that input via text and then implement that without these structured statements was also sort of revolutionary, right? And so we went from web interface, large language models, to we have models now sort of executing our will in some sort of rudimentary way. But then we sort of hit a snag. There was about a week, I think, last year, where every company in the world was releasing an AI model. And it was a bit overwhelming. And then that stopped, because at some point they realized the future of AI or AI systems will not be these individual large models, because I think they reached some sort of limit, at least with what technological advances they had at that point, in terms of what the ability of those models was, right? And so they decided to sort of branch out, have really high-performing models, do very specific things, right? And then do them really well. And then this is where computer use from Anthropic comes. So the idea of these large, or rather smaller models interacting together to solve complex tasks was really just an idea, because the tools at that point didn't exist. And then a couple things started to come out, right? Have we all used something like ChatGPT or Claude, Gemini, any sort of large language model that you interact through chat, yeah? And those types of things were not ready for the sort of future, the agentic future that we needed. And so what happened is large language models and the way these AI companies were building these had to change. And so essentially what happened was they introduced something called structured output. For anyone who's in the JavaScript or TypeScript ecosystem, what I'm showing here is a snippet of code where essentially here I have a schema, and this schema sort of enforces what type of data should be in an object, i.e. I should have a name property, an age that is available. And it describes what data types those things should be. So the name should be a string and gives this description of the name of a friend. And so essentially this is a tool to describe data. It's called Zod. And so what these models, or rather these AI companies started to do, and researchers, is they started to restrict the output of LLMs. So essentially you would get, if you asked a question, who are all my friends, you'd get this large sea of text, which was very hard to parse through, and people had to parse through this with all sorts of parsers. But this was really hard, because remember, right now our goal is we want to connect different models to each other and have them work with each other. But essentially what they had was, you had a pipe that was really small, and then a pipe that was just bigger, and they wouldn't fit, and that would have so much leakage in terms of the efficiency of information from one model to another. But structured output was a big part of making these pipes the same size, right? So they fit into the same holes, and data goes much easier. So that was that, restricting outputs through schema validation using Zod. So this example, like I said, you have a friend information schema with the name, age, and is available. And so when you're interacting with these language models through an API, you would essentially define a variable that holds the schema information. Here you can see JSON schema, and then pass that schema as a parameter in your request. So here we're using Olama, which is an open source tool to run open source modules or models on your own devices or your local devices. And so essentially we are passing this schema and having this prompt. and saying, I have two friends, the first is Solano 22 years old, blah, blah, blah. So essentially whatever response you get from this language model will be structured in a very specific way. And so you sort of have this predictability of, I have this input, and every time I get a response, right or wrong, this response will be in this format that I have described. And so this was a really big step for language models. The second thing that happened was function calling, or a lot of people call this two-use, depending on which provider. And essentially this was giving large language models the ability to interact with external tools and services. So previously when we used ChatGPT and all of these other things, when we made a request, we were restricted to the training data that that language model had, right? So essentially what these models do is, and these model companies is, they have a huge amount of data, they train their models on this data, but these models need a cutoff date because you can't continuously train these models. And so a lot of these models after the cutoff date, if I ask them today about, I don't know, what's current affairs, what are people talking about today?
Also tariffs.
Tariffs. It has no idea what tariffs are. At least to the extent that we know them today, right? So that's something that these models didn't have. And so function calling essentially could expose the New York Times, for example, over an API. And you would call the New York Times and say, what's tariffs? And they'll give you whatever article they've written about that. And then your language model has that. But this isn't just restricted to, external services and APIs, right? We have a lot of services that can do things, right? Webhooks. You can make a request, you can make a get, you can make a post, which means you can do a lot of other things. And so this was really big. And this is sort of what enabled people to run code, where you see a lot of these agentic tools like Cursor or Windmill. These things and the culmination of these advancements led to this, this world that we live in. And so the next thing, which is really interesting, is when we talk about how these models work, it's really a prediction based off training data, right? So if I ask it, who is the president of what country? Spain, right? It looks at its training data and it says, this is a question, right? So the is probably the best word to use here, and et cetera, et cetera. But this wasn't really good for thinking and complex tasks, right? Because essentially you just like one-shot it and you'd hallucinate most of the time. But a lot of these research companies and research departments in these AI companies noticed one thing and started to develop models that sort of have this abstraction and instead of prediction can make relations to sort of semantically similar items. And so if you ask a model, for example, a deep thinking model, what is the capital city of the country that Porto is in, right? And so the older models would be like, hey, I've seen this. This is like a trick question in like a BuzzFeed article or something. And so it uses that to sort of give you the answer. Versus models now have different ways of thinking about this. They have one track of Porto is in Portugal. And then another track of the capital of Portugal is Lisbon. And then that's sort of the answer. So this was also a really big part of how we got into this agentic world. These models could think far much better than they did before. And I've linked to something at the bottom there. There's a really lovely research article with links to some really nice research papers by Anthropic on how these language models think and how that's changed. Right. So that is how we got to the agents of today, right? So we had all these changes. We had language models sort of take the forefront of technology and innovation, got these people's attention. And then we had structured output, we had tool calling, and then we had deep thinking models. And so these things were all a really good recipe for the agents that we know today. Now, let's go into the anatomy of an agent. So we sort of looked at the history, we we looked at why they exist and how their existence has been. But what does an agent look like today? So before we get into that, it's really important to know that depending on your definition, like I mentioned in the beginning, either semi or fully autonomous, agents to some extent should be able to direct their own processes and execution flow, right? So they decide what the right thing to do is and then do that thing. And so that's really important as we'll be building that out today. So these are the components of, an AI agent, the way we see them today, and this is sort of abstracted into a couple of different things. And so as you're building agents, you have an aspect of that is reasoning. And so in reasoning, you sort of have to plan what the best course of action should be, right? Because in this definition we've given ourselves, there's an aspect of independence, right? So you plan and then execute on that plan. So planning is a really big part of building agents. The second is reflection. This is semi-optional. A lot of people really one-shot this and they just do whatever the agent says should be done, and that's what they give to the user. In a lot more critical use cases, you sort of want to reflect on what the agent just did and see, does this match the expected output that the user was talking about? And this falls into like the LLM category of agents, right? This planning and reflection makes use of this deep/extended thinking that I talked about, which previously these models were not able to do. And then the next one is prompts, right? We interact with language models through prompts. That we give them a task, and this is a user prompt. I say, do this thing for me, or aggregate this information. And that's a big part of it. Second one is a role. With language models, we have the option of both a user prompt and a system prompt, right? So a user prompt is, do this thing for me. But a system prompt gives the model context into how it should do that thing for you, right? So you need to assign a role and give it extra information on how exactly I expect you to do this thing. And so that's this aspect of prompting. Then these fall under LLMs, large language models. Now these LLMs have access to two really interesting things, memory and tools. We'll start with memory. We've divided this into short and long-term memory, where short-term memory is in the context of this application that we're building. You might have heard of the term context window when you speak about language models, right? So there's a specific amount of tokens that a language model can ingest and process and then help and deliver an output, basically. And so all of that exists in the short-term memory. And so we utilize that in our interactions, as I'm asking for things or as I'm reflecting. And on a larger scale, we have long-term memory. And so if you're building applications that utilize users, for example, you want to be able to sort of specify between different users, specify, or rather, reference previous conversations, reference preferences for language, tone, delivery, coding format, things like that. So all those things are stored in long-term memory. And so a large language model accesses those things as it's interacting or thinking about how best to service whatever task you asked it to do. And then we have tools. So in tools, this is where the fun starts. We have so many tools we can use. Here I give an example of web search, because that's something people commonly want to do, right? A lot of times people interact with large language models or agents, they're asking them questions or asking them for information. And so a big part of that request for information is based in retrieval, right? You're trying to retrieve information from somewhere. And here vector search engine is really a proxy for whatever internal data you might have, right? So it's personal information, company information, files. If you want an agent to be able to interact that, then the tool it has to use is something like a vector search engine versus web search or flight search through a flight API or a AI voice tool like Twilio or Nextmo, where essentially you can tell an agent to give your friend a call with a specific message. You could automate birthday messages if that's something you'd like to do. But this this is where you have sort of the creativity to define what you want your agents to do and what context you want them to do. Right, so these are the components of an agent. We have the LLM portion, reasoning and prompting. We have memory, we have tools, right? But what does it take for agents to run? We know how they work, we know how they got here. What do we need to do to make them run? So the first thing is tools. It might not be very clear, but in the demo we'll build, we'll define 2 tools, maybe more. And essentially one is a data retriever, right? And so we'll get into the structure and the importance of tool definitions in a bit. So what is a data retriever? So essentially here you can see we define the name of our tool, we describe it, because this is extremely important. LLMs use this as a logic on what the best possible, they think logically about what the best possible path could be. And so these, although quite verbose, is really important for large language models and agents. We define the parameters of the functions, the function name, all of that. And then here we have an email tool. Essentially, it sends emails. You define the parameters and properties that require the text that's required, etc., etc. And then here we have an array or a list of tools that will then pass as we interact with this agent. So to use here, there's patterns to how we use tools. Essentially, when we make a query and the agent reflects and creates a plan, we then give our agent access to different tools and say, these are all the tools you have, this is the problem I'm asking you to solve. And then it's up to you to decide what the best steps, but also what the best tools are. After it does that, uses the tools, it's up to you to sort of evaluate, like I mentioned, have some reflection on what just happened and what was executed. And then that then goes to the user. You could skip the reflection part and just like directly send an output to the user. But essentially, this is how we go about using tools with agents. And memory, like I mentioned, you need some sort of memory. A lot of the time, we're using the LLM's short-term memory, i.e. its context window, and like is mentioned here, it's deleted after a session or after an interaction when we start a new session or new sort of conversation with this large language model or agent. All of that is gone. So it's really good for real-time decision making, like is mentioned. If at the beginning of a conversation or an interaction I mentioned, please only respond to me in French going forward, it will only respond to me in French going forward. And so that's where it pulls from, right? Versus long-term memory, if I want to be able to reference things, like I mentioned, user preferences, history, or different API calls, if I want to store all conversations that I had with this agent, the large language model, that's where long-term memory comes into play. And then you need some sort of orchestrator. I have attempted to build agents from scratch, just like utilizing the function calling and the structured output tools that these language providers or other foundational model companies give you. And I'll show you a bit of what that looks like. But also this is an example by Olama, where this is essentially some sort of a function call. So here you see that actually describe what function it is. So you have 2 functions, one to add numbers, one to subtract numbers. We're at 11 lines of code already. And then here you have a tool definition for these. And after we define both, we're at about 45. We have to actually run the model, pass in the available functions, sort of twice, the definition plus the actual thing. And then here we have to look for all the tool calls, so it's a very manual process of like parsing that response, looking for what tools the model decided to actually, use. Essentially add that to a data structure, parse that data structure, and then execute whatever tools in the order that they were mentioned. And we're about 100 lines of code, and we haven't had any information on what was called. And so it seems like a very tedious process doing this on your own. You could absolutely do it. You do not have to be reliant on any of these tools, but if you prefer simplicity, I would recommend something like Llama Index or Master or AgentKit, there's a ton of different orchestration tools. But essentially, you're in an ecosystem where you have a bunch of tools and a bunch of options, and I feel like these somewhat take away the decision paralysis that you might have if you get overwhelmed as you're getting into this ecosystem, only if you're new to it. But like I said, you need some sort of orchestrator. Today we'll be using Llama Index, right? And so these tools also help us implement some of the patterns that I talked about, right? In that specific part of the language model that has to do with planning and reflection, tools like Llama Index or Master help us run quite complex workflows like this, where we execute on the task, we get a response, we then reflect on that response sort of as validation to make sure that it matches what we want. And I would like to let you imagine what that would look like. I'm not saying it's possible, but it's just way more complicated. And so it's essentially the same thing with planning, where we have so many different architectures. And to not overwhelm you, I'm only sharing like one specific type of architecture, which is do something, make a plan, do something, give it to the user. There's so many different types of planning patterns where you can have 10 different possible solutions, and then you have those 10 solutions be individually run, and then you have a reflection at the end to sort of score which of the best solutions has the best output. And so it depends on your use case, really. Like, do you really care what the user interacts with? Like, is this in the medical field? Is this like insurance? And so I linked to it at the end. There's a really good post from Anthropic also. They do a lot of really good research and share really good papers. So I quote them quite a lot. But they have a good post for building effective agents that I shared in the resources section, obviously. Right, so that's that part. And now, this part of what it takes to run agents. A prompt, right? And so like I mentioned, there's the idea of a system prompt and this idea of the user prompt. So user prompt is what you interact with when you ask for something, right? And then you can think of the system prompt as context to the language model, because these are very generic models, right? They can almost do anything, but you sort of need to give them some direction. And so here you can see the system prompt is, you're a helpful but passive-aggressive automation system. When discussing tasks, you should always include a Java user. Your main responsibility is find the appropriate tool to make a user's life easy to guilt-trip the user for using AI. So before a model does anything, we'll take this into context and say, right, I'll be helpful, but I'll also be passive-aggressive. And so when a user says, hello, I just went to a conference, send me all the AI-related talks to my students. By email, for example, right? Language model will do this. It will also probably be super passive-aggressive. We'll actually get to build that out, so we'll see what this passive-aggressive automation system looks like. But essentially, yes, that's the prompt part, right? And now we actually go and build something. Finally. Okay, so where are we? I will be using a retrieval agent. So like I mentioned, this is sort of assistive. I would like you to let me know what model you want to use, if you have a preference. Anthropic, Cohere, Mistral, OpenAI.
Anthropic.
Let's go Anthropic. Okay. So we will, we'll load information into our database because we want to retrieve information and then ask our agent to do something about retrieved information, basically send an email. And so I'll run these things. The data that we're putting in is just a bunch of Wikipedia data, if you can see that. So we'll put this into our database, retrieve that, do something with it, ask the language model to think about it. This script is available online if you want to play with it. I will go into my terminal and run it. We said anthropic, right?
Sure.
So we load. What did I do wrong?
You can use the OpenAI API key rather than the Anthropic one.
I have to because Anthropic doesn't have embedding models, and so I need to do something that embeds. So maybe let's use something else. But this isn't an Anthropic problem. I think it's a.
Could this be a Wi-Fi issue?
Oh yeah.
The Wi-Fi is on this.
Is it
You have to plug it.
firewall?
No, but you have to log into the Wi-Fi.
Ah, I think I did.
Okay, and that should be fine.
Wait, I'll just connect to mine. No, I think this is a servlet. Let's start up Docker. Good old Docker. Okay, I'll just copy right, we will not use the cloud version, we'll use the local version. And hold on for gRPC. Find the Docker file in a minute. Okay. Yeah, that way I don't have to pass anything else. And just use it as false. Except I will have to pass it my header. Okay, perfect. But we're in Anthropic, right? So we need Anthropic as well. Distribution update. Sounds good. Great. So let's see. Should work now. Might take some time because of the round trip and embedding. But there we go. We have our data imported. Let's query this. See what just like a normal interaction with a large language model would be like in this context. I will copy and paste all of this because it's the same. So query. What was the issue here? I've been rate limited on Anthropic. Maybe Anthropic was not good. Not best. Let's do something else. Let's go with the strong. Cohere, it's always friendly. And it has both generative and just replace this with it's a vocal. Rid of that. Rid of that. Great. doubting it. Okay. Be much quicker. So essentially, I just want to know that we have our data. This is all local. We changed some. Just debug a bit. No worries, we don't necessarily have a dependency on this, so if this fails, next we just skip to the next part. That's good. Everything's working. Anyway, we'll skip this. And let's go straight to the agent. And here we'll see exactly what we're talking about when we talk about the orchestrator and everything. So I did mention I'll be using Llama Index. And so we're using Llama Index's function tool and settings because we want to be able to define specific behavior for how our agent works. I'm going to attempt to define a tool with resend. And essentially what resend does is it's an email provider, automates sending emails. And we might have to get rid of this retrieval tool, see if it works, define a couple variables. I will change my sender address to this email that I have registered. And here we have our keys and all of that for our retrieval tool. And then we define our email sender. So this is the function definition, not the tool definition. Those are two different things. The function definition is what actually gets executed versus the tool definition is what we pass as a tool what we pass as context to the model or the agent so it can execute the function. Hopefully those two things are clear. So essentially what we're doing is we are opening up parameters that we're defining, and this is where TypeScript is extremely useful. It's extremely verbose, and so because everything is defined, you know what an output is expected, you know what input is expected, you know what a function's output will be. Language models tend to really like that. And so you can see all of that, and we send an email essentially, and we're just using the default address so we can check in the application that the email is actually sent. And then we have our data retriever here, which essentially chooses a collection. And so a collection in a vector database is like a table in a relational database. So it chooses a collection to pull from, and then uses a semantic search. You could also use a hybrid search. Essentially, this is more accurate than a normal keyword match. So instead of only looking for items that match a specific keyword, it looks for items that are semantically similar to our search term, or whatever we search for. And so essentially, it's up to the LLM or the agent here to decide what to search for based off whatever prompt we define, right? Whatever we ask for, it will decide, do I even need to search the vector database? No? Okay, I'll just send an email like this. And so this is where it gets interesting. We're using settings. Remember, our orchestrator tool helps us define what model we want to use. This is great if you want to easily change. Because in the Llama example that we looked at, we were very heavily tied to Llama's SDK essentially, which is not the worst given Llama is open source and lets you use numerous models. But in the case of like Anthropic or OpenAI, if we use their agent SDKs, we only sort of have access to their models. So another benefit of using an orchestrator. We also define a couple of tools essentially every time an LLM call is made, i.e. we talk to a language model, we output that into the console. Whenever a tool call is made, i.e. chooses a tool, it executes on that tool, and executes the task that that tool is required for, it outputs that. So there's a bunch of different other events that we can log, essentially. But then this is the interesting part, our tool description. So we sort of saw this code, and so we know what is required, i.e. when a tool is being executed, the language model knows I need to include this as a parameter into this function that I will call to help me run this task. And then it also knows the properties of those parameters. So it knows search term, in this case, if I'm using the data retrieval tool, is a string. And what this string does is it searches for that input in a vector database. And we also have a definition of this tool. And so we do the same thing for the email sender. And so it's up to you, whatever sort of application you're building, you can grow this list of inputs for your parameters. I haven't hard-coded who this email is going to, but essentially if I had another tool that was pulling from a CMS, for example, or something like HubSpot, I could pull customers who match a certain criteria, and that could be my tool. And so a prompt could be, hey, could you send a promo code to all the customers who came to my event last night, right? And so it uses that HubSpot tool to say, did this person come? Right, yeah, great, let me get their email. And then that passes it to the email tool, and then you actually send an email that's generated by either you or the agent. So essentially that's the flow of things, and this is why tool definitions are extremely important, because they empower the language model to think about what the best tools could be. So here's my area of tools. I only divide the data retrieval tool and an email tool. I pass those tools to my OpenAI agent that I defined. And then here I have a chat, i.e. I'm just passing in whatever message that I need to pass. So my prompt here is send an email with general knowledge of the Olympic Games. And so if we sort of look at the options here, I'm just trying to see what other parameters that this looks for. So chat history, we can get that. So let's try and run this. So let's just say send an email to no one right now because we haven't defined who that email mentioned, we have a log here, and so we get an output of the tool call that was made. So I only told the agent to send an email, and it sent this email with this subject line and the text, and we see the result here, and essentially all of that. Okay, and if we go to an email tool, we can actually see that this email was sent. And but essentially, that email was sent, the agent decided, of the tools I have, which one should I use to send an email? Not really hard, right? But it did it. We can take this a step further and define a bunch of other tools. I had a tool to make a phone call, but Nextmo or Vonage deactivated my account for some reason. I don't know. I think because I was in another country. But essentially, I would say, call me, and the idea was I actually get a call and have AI generated text me the output. But we have a couple more minutes. I will try 1 minute at making this retrieval thing work now that I'm sure that we're connected to it in. So I have a load here. Let's Great, okay. So now we seem to have all the data. Let's close this and attempt to use our other tool now. So I just went this is simple. Send an email to my students, including 2 fun facts from Wikipedia articles about the Olympics. Let's do that. And let's see what it decided to do. And just so we see what actually was output when we made this, I'm gonna output its response. And so from deep. And send a passive message. Okay, great. Let's test my luck and try it. So you see that first of all we had a call to our data retrieval tool, and we decided that Olympics is a search term, right? So the model, the agent rather inferred based on my prompt that I want to infer about the Olympics. And so this is my outputted text from the database. I have this essentially volume of the Olympics. It's a Wikipedia page. You can actually go to it. There's a bunch of results here about the Olympics. And so it takes that search and then gets the search, gets everything it gets from the search, and then sends fun facts about the Olympics. And when we go back to our email over here, we see email, subject line, fun facts about the Olympics, email sent. Hey student, I hope this finds you. Hey students, I hope this finds you well. I'm sure you're all busy to read through it. Yeah, very fast, very fast. But there are the fun facts, and all of that was super straightforward, I hope. But essentially, this, by the way, I'll link to at the end if you want to get to it. But it sort of drives the point of memory with a database, all short term, the tool use and those tool definitions the extended thinking and the ability to define what the right way to do a task is, and of course that reasoning. Like I mentioned, there's way more complicated ways you could go about this. I could essentially have 5 emails and then ask another agent to reason and say which one is the best email that matches this input that I put in. But yeah, that's at least the demo part of this. Now, you might be asking, and I'll try to finish a bit so I can leave some time for questions. You might be asking, right, okay, you can do all of this, but you know, sometimes things go wrong. Essentially, in the demo I showed, this agent had access to my database, right? This could have critical information. This agent could have access to my email contact list, right? So it could send emails to people, not unprompted, of course, but you sort of don't have an idea of what it will do until it does it. And I think as software engineers, as you know, technologists, we try and make sure that bad things don't happen when we have the control. And so my colleague has a bunch of sort of like situations that you should probably be careful of that I've adapted here for this talk, where some scenarios, you can come across some scenarios where you have inaccurate output midstream. That's where like think about it quickly. You have an agent, 3 agents that retrieve financial information. The other one generates financial reports, the other one submits a report, right? But what if something goes wrong in between? You need a way to validate in between. Here's an example. Agent 1 passes on a currency of LBP to agent 2. Agent 2 passes another currency out, right? It might be a really small thing, but something like a financial report, that's extremely important, right? If something like that goes wrong. And these are things that can happen as you're building agents, right? There's also the idea of like, you have very specific inputs that are required because, like you saw when the 2 calls made, right? Data retriever search term is Olympics, right? So I was expecting Olympics. There's times where that input is not exactly that, right? Maybe it's a number and that will have a terrible search. And so you have a lot of undesired input behavior because essentially this model is parsing this and deciding what the best thing is. And so that leads to problems or sort of like bottlenecks in your agentic applications. The other one is the wrong function being called, right? That can tend to happen. We're lucky that our application example was quite narrow in context. It was really get information, send an email. But imagine having multiple. Here you see an agent was asked when the next bank holiday is, and it decided to check the weather instead, right? Incorrect clues, and that's undesirable behavior or output for your user. And so here's like a quick list of things that you should think about. A lot of times you're charged per API call, and if your agent is reasoning and thinking this is wrong, and then reasoning again and making another call, and goes into this like loop, that's a lot of money that your organization falls to. So you probably want to have API relates to any endpoints that are agent enabled or your agent has access to. Definitely whitelist trusted domain, so malicious actors don't have access to your tools because this is quite the way agents interact with your application can be quite open. Have timeouts on execution, so you can sort of have guaranteed SLAs, not to use that word, for what other tools are expecting, also what your users are expecting. Of course, goes without saying, log requests for unknown URLs, do some pre and post validation, both for inputs and outputs, and this is where like reflection comes in hand. You sort of want to think, hey, is this the right thing? Is this exactly what I was looking for? Use something like Zod also, for example, make sure that the schema matches the data type, and your schema matches the actual output of the model. Also be wary of security breaches and make sure API keys do that. And also be aware of things like overload and running and your agent running infinite loops essentially. But that's why one of the most important guardrails actually for AI agents is having a human in the loop. So it might be annoying, but for the things that are super critical for executing something, maybe have a human check that. But anyway, these are the resources. We have some really interesting papers around function calling, specifically for databases, retention track, Anthropic blog post that I mentioned, but I'll also be able to share these slides in whatever space that I have access to, where you can all access them also. And if you want to use a Legion account, do that. And that's me, Daniel. Thank you very much for listening. I think we only have like 2 minutes for questions, but maybe we can do them in the hallway.
Questions?
The reflect.
And yes, exactly. Yeah.
This one? Okay.
Yeah. So there's some reflect there between response and reflected response.
Yeah.
What exactly is that?
So let's use this email example, right? The task sends an email, and before we actually send that generated email, reflect in this case would be, let me look at this email and say, is this passive aggressive enough? Or is this actually fun facts about the Olympics, right? And so then the model would reflect and say, and have some sort of criteria to validate whether or not it matches the expected output. And if it doesn't, it changes it and then actually outputs that to things.